Thank you for the introduction. So this project is about searching and browsing in movies, and I'll start off with an example. So suppose I'm a film studies student, and I think that Luke's costumes might transition from white to black across the first 3 Star Wars movies, signaling that he's gaining experience. I would like to find out if this is true, and we got this hypothesis from an existing book, but we could have made up our own. But to explore this idea, I either need to watch all 3 movies, which takes obviously a very long time, or I could try scrubbing through the 3 movie timelines. So here I'm going to try to find an instance of Luke. Okay, and there I scrubbed past him, but I'm trying to find that moment again. And I got it. So finding a short moment in a long movie can be particularly difficult using scrubbing. Alternatively, I could try the DVD chapter menu. But these aren't very informative, and I might have to fast forward and scrub within each section anyway. So finding these moments can be difficult using DVD chapter menus as well. So we created SceneSkim. Using SceneSkim, users can choose the movies that they would like to search in. So here I'll select the Star Wars trilogy. Then they can search within the plot summary for moments involving the character Luke. Then I can click through the results to see examples of Luke's costumes. So I'll start with one from A New Hope. And we can see that Luke here has white robes. And next I'll try Empire Strikes Back. And I'm just going to pick a really important moment in the movie. Okay, and it's a little hard to see here, but his robes have turned to gray. And finally, I'll finish with Return of the Jedi. Oops. And here we can see that Luke's robes are now black. And so his costumes have indeed transitioned from white to black. And this interface made it a little easier to answer that question. So we interviewed practitioners and found that searching and browsing in movies is an important but time-consuming task, not only for film studies scholars analyzing films, but also film professionals seeking inspiration for new projects, and new media artists who edit together existing movies to create new art. So along with searching for clips that match a query, like Luke's costumes, these practitioners also search for specific clips they've seen before to reference them again. Though these practitioners usually watch the film or use the video timeline, there's actually a number of existing documents online that are closely related to the movie. The closed captions on sites like opensubtitles.org, the script from sites like IMSDB and DailyScript, and the Wikipedia plot summary. So for this work, we scraped 800 scripts from these websites, and then we connected them with closed captions and plot summary drawn from corpora by other researchers. Each of these documents have distinct attributes that are very useful for searching and browsing, so I'll go through these one by one. So the closed captions contain transcribed movie dialogue, like, "Have you seen Luke this morning?" along with sound effects like footsteps and approximate timestamps that let you know where these events occur. The script, which is used to plan the movie, contains locations such as Lars' homestead, action descriptions like Owen enters in a huff, and character names like Owen, and finally a draft of the dialogue to go along with the character names. And we note that this dialogue in the script isn't the same as the dialogue in the closed captions, as actors often improvise lines and scenes get edited out of the final movie. So for instance, "Where could he be loafing now?" was edited out by the time we got to the captions. Finally, the plot summary, and we'll just look at one example sentence that says, "The droids are captured by Jawa traders who sell the pair to moisture farmers Owen and Beru and their nephew Luke." The plot summary contains high-level events like captured, which actually describes an entire scene in the movie, and character traits like moisture farmers to describe Owen and Beru. Most importantly, this plot summary is short, and it's really easy to read through. And actually, all of these documents are easy to search with traditional keyword search or browse by skimming through the text. So in this project, we'd like to tightly connect all of these documents to each other and to the original movie in order to let users search and browse within movies using text. So to do this, we're going to link the movie to the captions to the script, and the script to the plot summary. And first, I'm going to start out with how we link words in the movie audio to the corresponding words in the captions. So I'll show you an example of what this caption and movie alignment lets us do. So first, I can click on a word in the captions to hear that corresponding word played back in the movie. And so here I'm going to click on the word Dagobah to hear the pronunciation at that point. And just a warning, this goes by really fast, so pay attention here.
The Dagobah system.
Next, I'll try the word Star Destroyers.
Star Destroyers,
Along with simply browsing using the captions, I can also search for specific phrases in the movie. So here I'm going to choose to select phrases within A New Hope, and I'll search within the captions for the phrase The Force. Then I can just click through these examples to hear this phrase played back.
The Force?
The Force is what gives the Force. The Force, Luke.
The Force.
So how do we get there? Using timestamps only, we're about 1.1 seconds, or 4 words off of our target. Instead, we would like a word-level alignment. And we have an existing algorithm for word-level alignment, but unfortunately it performs poorly in the presence of background movies and sound effects, which are really frequent in movies. So we want to get rid of these. To do this, we first remove non-dialogue lines using the standard format of caption files. So here I'll remove waves crashing at the top. Next, we want to only align words within the transcripts, within the timestamps. But the timestamps are approximate, and they often cut off words and include non-speech noises. So we combine segments that are part of continuous speech and then align the audio segments to the corresponding words. We found that our method is only 0.06 seconds off of the word on average, which is less than a word, and it's usually unnoticeable. So now that we've aligned the movie to the closed captions, we're going to align the dialogue in the captions to the dialogue in the script. And I'll start with an example of what we can do with these two alignments combined. So the most obvious thing we could do is click on a dialogue line in the script to play that caption line back in the movie. So here, I'm going to click on the phrase, "I seem to have found it," and you'll hear that phrase played back.
I seem to have found it.
But I can also navigate the script to a particular location. For instance, an external shot of space. I can also search within the script using some of the other attributes. For instance, I can search for a particular character like Yoda by searching in script characters and typing in Yoda's name. Then I can hear his lines by clicking on the search results.
Yeah. He is not ready.
Yoda.
He is too old. Will he finish what he began? Yeah. You will be.
I can also search for particular locations. So if I don't remember the movie where Cloud City occurred, I can search in the script locations for the location, the Cloud City. And then I can click through the results to see multiple settings within that location. So here are some cloud cars, a landing platform,
Why, you slimy, double-crossing, no...
and the living quarters.
Ship's almost finished. 2 or 3 more things and we're in great shape.
So we get these scripts in the form of text documents that all follow a similar format. Using this format, we label useful attributes for search. So we start with labeling the characters and the locations because they're both capitalized. And then we label the dialogue and actions. Now that we have the dialogue, we're ready to align the script dialogue to the caption dialogue. And we can't naively line up these words because the dialogue isn't the same. Instead, we want to find approximate correspondences so that the phrase, "Aren't you going to be saving her?" matches to the phrase, "Will you be saving her?" even though these aren't exact matches. So to figure out these correspondences, we line up all of the words, and then following previous work by Laptev et al., we use word-level edit distance to find the best alignment. Edit distance allows words to match or mismatch, and it allows for insertions and deletions. Then we assign each script line a score from 0 to 1. by dividing the number of words in the script line with matches, or green arrows, by the total number of words. And then we match any script line to a caption segment if this score is greater than 0. After this alignment, we use these scores to tell users how confident we are that the script line has a match by varying the opacity of these blue bars according to our score. We aligned 800 script and caption pairs in our data set and found that 81% of all caption lines had a matching line in the script. This isn't too surprising, as lines are often added in later drafts and improvised. Finally, I'll explain our script to plot summary alignment. In this example, I'll click on a summary sentence that explains that Luke accidentally triggers part of Leia's message, and the movie will jump to the part where Leia's message is playing.
Help me, Obi-Wan Kenobi. You're my only hope.
In this next example, I'll browse to the point where Obi-Wan asks Luke to accompany him on his journey by clicking on a sentence that says, he then asks Luke to accompany him and learn the ways of the Force.
You must learn the ways of the Force if you're to come with me to Alderaan.
So to do this, for each plot summary sentence, we want to find a matching set of script lines. We do this using 2 pieces of information. First, the events of the summary and the script usually occur in the same order. Second, important words in the summary should match important words in the script. So for instance, the word tractor beam occurs only once in the summary and once in the script, so those points should match. So to operationalize this, we split the plot summary into sentences, and then we generate all possible segments of the script of a particular size. To enforce that the order stays the same, we use edit distance to assign segments of the script to the plot summary sentence or to no sentence at all. We choose which sentences are matched or have green arrows based on the number of important words that they have in common. So formally, this is the cosine distance of the TF-IDF, or term frequency inverse document frequency vectors between the sentence and the script segment. We evaluated our method by creating a ground truth for 4 movies, and we considered the segment correct if at least one script line matched, because users can easily navigate using the script once they're in the general area. Results range from 56 to 53%, but the best performing movies had more unique locations, characters, and options, which helped to discriminate between matches. So now we have a complete system, and to test if SceneSkim supported realistic queries, we surveyed film studies literature to find 9 existing queries, and we also invited 3 film studies researchers to generate novel queries and answer them using SceneSkim. So I'll just walk through a couple of these examples. Our first hypothesis from literature says, one notices in Empire that the red lights are flashing in the background whenever the characters Han and Leia talk to each other. And so we searched for Han and Leia in script scenes and found that in many important scenes, there's actually no red lights in the background. And this only took us 3 minutes to do exhaustively. Another hypothesis stated that the screen time devoted to lightsabers increases throughout the trilogy. So we searched for lightsaber in script actions, the plot summary, and the captions. And then we watched and timed every instance of a lightsaber to find that the lightsaber screen time did in fact increase throughout the movies. This took us 21 minutes, but 20 of those minutes were spent actually just watching the movie. So next, 2 examples from film studies researchers. One asked if Jack Sparrow's eccentric motions were the actor's improvisation. So they searched in the script for lines by Jack, and they referenced the script to see that it looks like his motions weren't scripted at all. And then another user was curious which character in Taxi Driver said the line, "Are you talking to me?" So they searched for the line in both the script and the captions, and they found that the main character says this line. All users were excited about using the tool, both for research and teaching. So we build on 3 existing areas of related work. Prior work exists on navigating videos via the transcript, but browsing only the transcript, you don't get any information about the visuals, so it's sort of hard to read through. In addition, people have worked on browsing videos using domain-specific metadata in fields like flight simulation software logs and videos. Instead, we focus on movies. And I'm out of time, so I'll skip to future work. We would like to add visualizations of frequency of words in our corpus, much like words here, more types of text documents to help users browse, and visual features to make, such as shot types, to make the search more powerful. And that's it, and I'm happy to take any questions. Thank you.
Hello there.
Hi.
Joshua Hipschman from Northwestern University. Really enjoyed the talk. Basic question is more about what would be involved in doing this for all movies? You know, which part is manual labor and which part is automated, and how can we scale it?
Yeah, so all parts I shared here are automated. So the main problem with movies using this method is that the script is not online for all movies. So that one problem was that when we scraped the script, for scripts, we only found 800 scripts for movies, at least on the websites we tried. So in the future, like if more people are putting the scripts online, which we have sort of evidence for since most of the scripts in our corpus were very recent, then we might be able to do this for more movies, but that's the limiting factor at this point.
Okay, thank you.
Thanks.
Dong from Cornell. Thanks for the great work. I'm doing online educational research, and I think this tool will be also very useful for like massive online courses with the video lectures. Then what else kind of application will be possible with this approach?
So that's a good question. This approach directly sort of uses attributes of the caption, script, and summaries, which are unique to movies, but you could see combining other types of documents about videos, like maybe courtroom files, or I guess for online lectures, people's notes, maybe things such as that. I think another application that came up was play rehearsals. Apparently, in play rehearsals, it's hard to review the whole session, so they often don't do it, and this could be helpful in that scenario as well. Thanks for the good question.
Thanks.
Great. Lydia Chilton from the University of Washington and Stanford. Great talk. I love this work. I love the alignment idea. My background is crowdsourcing, and very often there are things that you don't get from scripts, and particularly in movies, like high-level abstract things like what's the conflict that the characters are having and how is that embodied. And what I've done with workers is have them annotate that. So if you added a layer where people could annotate, how could that help people do even more queries?
Yeah, so So part of this summary is it's sort of taking it up one level up from that in-between step, maybe between the script and the summary, and that has some high-level events. But one really limiting factor of this work was that we didn't have that much data for summary to script alignments. So I feel like labeling with crowdsourcing could help align, get way more data and develop better algorithms for the summary to script alignment. And in general, I think that having another source of information would be useful for film studies researchers. Yeah.
Great answer. Thank you.
Thanks.